Here's the continuation of the previous video about differentiation of logarithmic and exponential functions. Let me just give you additional examples. I'll continue. The function in number 5 is y equals x squared plus x to the fourth e raised to ln of x raised to negative 2. This we'll just have to simplify the second term using a property of ln. If we try to recall, e raised to ln of x is equal to x. So therefore, simplifying e raised to ln of x raised to negative 2 is simply x raised to negative 2. So when we rewrite the function y equals x squared plus x to the fourth e to the ln of x raised to negative 2, that's just going to be x squared plus x to the fourth, where e raised to ln of x raised to negative 2 is just x raised to negative 2. So when we multiply x to the fourth and x raised to negative 2, what we'll do is copy the base and add the exponents. So plus, that's just x squared. So 4 plus negative 2 is negative 2, is just 2. Or y is just equal to 2x squared. So when we differentiate, we'll just get y equals 2 times the derivative of x squared, which is 2x. So it's just, this is y prime already. Y prime equals 2 times 2x. So y prime is equal to 4x. This is the derivative of the function. So here's the function in number 6. Y equals e raised to 1 over x plus 1 over e to the x. So in the first term, we have, this is u in the first term. Let u be equal to 1 over x. So if we recall the formula for the derivative of e to the u, it's just e to the u itself. This is the easiest formula actually. Times du, where du is the derivative of the exponent. So y prime, we can rewrite y first. Y is equal to e raised to 1 over x. We can write the second term as e raised to negative x. To avoid using quotient rule, we can write it as e raised to negative x. So in the second term, this is u. So now y prime is equal to, so the derivative of e to the u is e to the u itself times du. So it's e raised to 1 over x times derivative of 1 over x, because u is equal to 1 over x in the first term, plus in the second term, it's e to the u also times the derivative of u, where u is negative x. We are differentiating with respect to x. So 1 over x, as we know, can be written as x raised to negative 1. So it's e to the 1 over x times the derivative of x raised to negative 1 plus e to the negative x times the derivative of negative x. So it's just negative x. Okay, now continuing, we'll have e raised to 1 over x. The derivative of x raised to negative 1 using power rule is just negative 1 x raised to negative 2. Okay, so negative 1 x raised to negative 2 plus e to the negative x times the derivative of negative x with respect to x is negative 1. Okay, simplifying the final answer, we don't want a negative exponent, so in the first term, we'll write the answer as negative of, the numerator is e raised to 1 over x, the denominator is x squared. Okay, second term is minus 1 over e to the x. We don't want the negative x also in the second term. I think we have it simplified already. This is the derivative of the function y with respect to x. The next function is y equals e raised to square root of x plus square root of e to the x. Okay, so in number 7, in the first term, we'll use the formula for the derivative of e to the u. In the second term, we'll use the general power rule. We have to write all the radicals using rational exponents. So we just rewrite the function y equals e raised to x raised to 1/2. And then the second term is e to the x raised to 1/2. So you see, in the second term, we use the power rule because this is the base. This is in the form u raised to 1/2. While in the first term, this is u, the exponent. Okay, so by now you should be able to see what formula you should use to differentiate the expression. So I hope you remember the general power rule, and of course the derivative for e to the u is written on this page. Y prime is equal to the derivative of the first term, e to the x raised to 1/2. It's the derivative of e to the u is e to the u itself, so it's still e raised to x raised to 1/2 times the derivative of u, where u is x raised to 1/2. Plus, in the second term, it's the derivative of u raised to 1/2. So it's using the general power rule, it's 1/2 e to the x raised to 1/2 minus 1 times the derivative of the base, where the base here is e to the x. We're not yet done with the differentiation because you still see derivative of x raised to 1/2 and derivative of e to the x in the equation. So y prime is e raised to x raised to 1/2. The derivative of x raised to 1/2 using power rule is 1/2 times x raised to 1/2 minus 1 plus 1/2 times e to the x. 1/2 minus 1 is negative 1/2. The derivative of e to the x is just simply e to the x. Using the formula for the derivative of e to the u, where du here would just be equal to 1 because the exponent is just x. If you differentiate x with respect to x, you simply get 1. So the derivative of e to the x is just e to the x itself. Okay, y prime is equal to e raised to x raised to 1/2 times 1/2 times x raised to negative 1/2. And then plus e raised to, so 1/2, e raised to x times 1/2 is e raised to negative 1/2 x. Or no, we don't have to write it in that way, because we have to write this in radical form later on, times e to the x. So in radical form, x raised to 1/2 is square root of x, so this is e raised to square root of x times 1/2. Well, this negative 1/2 in the exponent should be positive, so x raised to 1/2 should be written in the denominator. So 2x raised to 1/2. Okay? And then plus this 1/2 also, or negative 1/2 should be positive. So e raised to x raised to 1/2 should be written in the denominator also. So that's 1 over 2 e to the x raised to 1/2 times e to the x. Well, if you divide x, e to the x by e to the x raised to 1/2, we'll have, we'll just have to cancel out this. Okay, so e to the x divided by e to the x raised to 1/2 is e raised to, this becomes, if we subtract the exponents, we'll have the exponent 1/2 x in the numerator, or that is x times 1/2. All right. Continuing, so the first term is e raised to square root of x over 2. X raised to 1/2 is simply square root of x. Okay. Plus, in the numerator, in the second term, we have e raised to x raised to 1/2. You know that e raised to 1/2 x is equal to e to the x raised to 1/2 also. So over 2. And e to the x raised to 1/2 is just square root of e to the x. So it's just e to the square root of x over 2 square root of x plus square root of e to the x over 2. Alright, so I think we already have it in simplified form. This is the derivative of the function. Okay, let's solve number 8 using quotient rule. because the function in number 8 is a quotient of x squared and ln of x. So in the quotient rule, we need u and v in the numerator and in the denominator, respectively. So let u be equal to x squared. So in that case, we'll have du equals 2x. And then let v be equal to ln of x. In that case, we'll get dv as 1 over x. 1 over x times the derivative of x with respect to x, that is just equal to 1. So dv is just equal to 1 over x. So y prime, or dy over dx, is equal to, the quotient rule is v times du, so ln of x times du times 2x, minus u times dv, 1 over x, all over ln of x squared, the denominator squared. So simplifying that, you'll just get 2x ln of x. And then x squared over x is just equal to x. So we'll just get minus x all over ln of x squared. This is the derivative of y with respect to x. In number 9, we have ln of x cubed plus ln of x quantity cubed. So in the first term, x is cubed, only x is cubed, and in the second term, ln of x is cubed. Okay, so in the first term, when we differentiate, we'll be using the formula for the derivative of ln of u. This is u in the differentiation process. Now, in the second term, we need to use the generalized power rule, where this is the base of the power. So this is u in the differentiation process in the second term. So y prime, using the formula for the derivative of ln of u, it's 1 over u times du, derivative of x cubed. In the second term, we use the power rule, general power rule. So we bring down the exponent, we copy the base, so base is ln of x, and we subtract 1 from the exponent. From the exponent 3, subtracting 1, we get 2 times the derivative of the base. Don't forget that. So it's 1 over x cubed. The derivative of x cubed is 3x squared using power rule, plus 3 times ln of x squared. The derivative of ln of x is 1 over x. So simplifying the answer, x squared over x cubed is just 1 over x. So it's 1 over x times 3. So this is 3 in the numerator. 3 plus 3 ln of x squared over x. If you want, you can factor out the common expression, which is 3 over x. And we'll get y prime equals 3 over x. But factoring 3 over x from the first term, we'll get 1 plus ln of x squared. So you can write this as ln of x squared without the grouping symbols. This is the derivative of the function. One last example for this video. In number 10, we need to use the quotient rule again, because we have here the quotient of u, which is e to the x minus e to the negative x, and v, which is equal to e to the x plus e to the negative x. So in the quotient rule, we need du and dv. What is du equal to? Du is equal to the derivative of e to the x minus the derivative of e to the negative x. The derivative of e to the x is just e to the x itself, while the derivative of e to the negative x, in this case, we use the formula for the derivative of e to the u. In that formula, we need du also, where u in the second term is negative x. So minus the derivative of e to the negative u is e to the negative, negative x is e to the negative x times the derivative of e to the negative or negative x. So du is just e to the x minus e to the negative x times the derivative of negative x, which is negative 1. So when we simplify that, we'll simply get dv, or I mean du, equals e to the x plus e to the negative x. While dv is the derivative of e to the x plus e to the negative x. So it's the derivative of e to the x is e to the x itself, plus the derivative of e to the negative x, it's e to the negative x times the derivative of negative x. So it's e to the x plus e to the negative x times negative 1. That's the derivative of negative x. So dv is equal to e to the x minus e to the negative x. Okay? Now let's proceed to the derivative of y with respect to x using quotient rule. It's e to the x plus e to the negative x. This is v times du. Du is e to the x plus e to the negative x minus u, e to the x minus e to the negative x times dv, e to the x minus e to the negative x, all over v squared, e to the x plus e to the negative x, quantity squared. Okay, we'll have to simplify the numerator. By removing the grouping symbols, we'll get e to the negative x squared. Okay, e to the negative x squared or e to the 2x. Okay, by multiplying these two, we get e to the 2x. Multiplying the outer terms, we get e to the x times e to the negative x, we'll get 1. So this 2, we get e to the x times e to the negative x, that's equal to 1. Okay. And then for this, e to the negative x times e to the x again, that's equal to 1. So we have another 1 here. And then the last terms, these two terms, we get e to the negative x times e to the negative x, that's e to the negative 2x. Okay, minus, do the same thing in this next term, it's just e to the 2x, and then this is equal to 1 again. These outer terms equal to 1 again. So we have minus 1, minus 1. Take note of the signs. And then the last terms, this will give us positive e to the negative 2x. So all of them over e to the x, this is plus e to the negative x quantity squared. Okay, combining like terms, we'll be getting e to the 2x plus 2 plus e to the negative 2x. Now, I will remove the grouping symbols, remaining grouping symbols in the numerator. I have minus e to the 2x. This is equal to negative 2. When you remove the grouping symbol, it becomes plus 2. So, minus e to the negative 2x all over e to the x plus e to the negative x quantity squared. Okay, when we combine e to the 2x and negative e to the 2x, we get 0. And also e to the negative 2x and negative e to the negative 2x, we get 0. So what remains is for dy over dx, combining the two constants, we get 4 over e to the x plus e to the negative x quantity squared. This is the derivative of the function.